Hello, fellow embedded heads. In this video, I'm going to show you step by step how to customize the Microsoft Visual Studio Code environment on your Windows PC so you can debug your code using your SEGGER J-Link as the debug probe. If you are on Linux or macOS, the procedure is basically the same, just with a few tweaks. Silicon vendor-specific extensions that enable the use of J-Link under VS Code are or will be covered in other videos. For links and hints, please see the description below. If you're enjoying this video, please like and subscribe. Let's get started. In order to do debugging with J-Link under VS Code, this is the environment you need to have set up on your computer. Microsoft Visual Studio Code serves as the overall IDE. The C++ for Visual Studio Code extension provides language support for C and C++ development within the VS Code environment. The Cortex Debug extension provides debugging capabilities for ARM Cortex-M microcontrollers within VS Code. Optionally, you can install the C++ IntelliSense extension, which provides intelligent code assistance. The ARM GNU toolchain from the ARM developer website provides the ability to build code for ARM-based target devices. But more importantly for this tutorial, it includes the GNU debugger, also known as GDB, which is required for debugging. The J-Link software and documentation pack from the SEGGER website includes the J-Link DLL as well as the J-Link GDB server that is required for debugging with J-Link under VS Code. It also contains a lot of other useful J-Link utilities. You will also need an example project with source code and the matching ELF file. Feel free to use your own example project if you have one available. I will be using the SEGGER evaluation software package for the SEGGER Empower board. You can find the software package on the SEGGER website under Products, Evaluate Our Software, SEGGER, SEGGER Empower. To get the ELF file I want to use for debugging, I need to build this project using the SEGGER Embedded Studio IDE, since that is the format it's in. You can download Embedded Studio from the SEGGER website and get a license for evaluation or non-commercial purposes. Another piece of the puzzle is the matching SVD file for your target device. Extensions like Cortex Debug use SVD files to provide a detailed, human-readable view of a microcontroller's peripherals and their associated registers during a debugging session. If your project doesn't yet include the SVD file, like mine, you can download the Simsys Device Family Pack for your target device from www.kyle.arm.com/devices. Unzip the .pack file like you would a regular zip file, and you will find the SVD file in the resulting folder. Note that the SVD file has the extension .xml. Add a folder called SVD to your example project and copy and paste the SVD file into it. You will also need a SEGGER J-Link and a target board, or a target board with a SEGGER J-Link on board. Now that our environment is in place, it's time to customize it for debugging with J-Link. Under the File menu in VS Code, select Open Folder and select the folder that contains the example project you'd like to debug. In my case, this is the SEGGER Empower project folder that I mentioned previously. Then, switch to the debug sidebar, click Create a launch.json file, and select Cortex Debug as the debugger from the drop-down list. The launch.json file will be created in a .vs code folder within your project folder. Now we have to make some modifications to the JSON file. I included the content of the modified file in the description below. Let's look at a few details. The server path should be your J-Link GDB server installation directory. For server args, any of the supported J-Link GDB server command line options can be used. For example, you can set the target interface speed to 8 MHz like this. If you have more than one J-Link probe connected, add your probe's serial number. If you are only debugging one target, you can leave this entry blank or comment it out. To set up the ARM GNU toolchain, just add the ARM toolchain path to the launch.json file. This is the path where your ARM GNU toolchain executable is located. The software setup is now all done, and we can actually start debugging. Make sure your J-Link is connected to your computer as well as the target board. I'm using the SEGGER Empower board as my target board, which is convenient because it has a SEGGER J-Link OB on it. You can start debugging by selecting Start Debugging from the Debug menu or by simply pressing F5. After hitting the breakpoint at main, you can single step through your code, set breakpoints, halt or continue code execution, and more. In the panel on the left, you can view the local, global, and static debug variables, the MCU core registers, watch expressions, the call stack, breakpoints, and the MCU peripheral registers. All the relevant information for basic debugging of your project is now at your fingertips. And there you have it, fellow embedded heads. Now you can debug your target applications with the SEGGER J-Link within Visual Studio Code. If you enjoyed this video, please like and subscribe. Please also feel free to leave comments below. Thanks for watching.